Okay, in this problem we're going to be doing the same things. I'm finding the critical numbers and finding the intervals that increase and decrease and the relative extrema. I'm going to go ahead and rewrite this first. I do not want to use quotient rule on a problem like this. It's much easier to take the derivative if we just go ahead and rewrite it. I will then reduce this to be 1 over x plus 3 over x squared. So then I can rewrite this as x to the negative first plus 3x to the negative second. Taking the derivative gives me negative x to the negative second plus negative 6x to the negative third. Now it's going to be hard to set that equal to 0 unless I go ahead and rewrite it. We have 6 over x cubed. Again, this is hard to set equal to 0 until I make a common denominator. So I'll start to do that, and my common denominator is going to be x cubed. So I'm going to leave this one alone, x cubed, and I'll have the 6 still on top. This one I need to multiply the top by x, so I have a negative x. I'll come up here to finish that. My first derivative ends up saying negative x minus 6 over x cubed. Now I'm finally ready to set this equal to 0. I'll take note that on the bottom I need to test x equals 0 because it's going to be discontinuous. It's discontinuous on the function. And I also need to go ahead and figure out what the top gives me and where it's equal to 0. So if I do that, I get at negative 6, there is a critical point or critical number. We need to test those on an interval, so I'm going to put 0 and negative 6 on my interval, and I'm again going to be testing the first derivative. So when I go ahead and plug in my negative 7, because I'm going to test the negative 7 here, I will end up getting a negative value for my slope of the tangent line to the curve. When I try, maybe I'll try negative 1, I'd have a positive 1 minus 6, which is a negative 5, over a negative 1, so that ends up giving me a positive interval. And then the last one here, from 1, when I put 1 in there, I ended up with negative 7 over 1, which is a negative interval, meaning it's decreasing. So the intervals of decrease are from negative infinity to negative 6, and from 0 to infinity. So those are decreasing. And then our interval of increase is from negative 6 to 0. So this is where it's increasing. The last thing I'm going to do is mark my relative max or mins. So in this one I have decreasing, then increasing, then decreasing. So I have relative max at 0 and a relative min at negative 6. So I'll squeeze that in here. My max is at 0, comma, something, relative max. My relative min is at negative 6, comma, something. So where am I going to plug this in? We'll have to plug it back in for y value. So when I plug 0 up here, well, that's not going to be a max or a min because it doesn't exist. So there is no max. Remember, it was discontinuous there. So that's the reason why. Then I'll plug in negative 6. Negative 6 plus 3 is negative 3. Negative 6 squared is 36. That gives me a negative 1/12. So I'm going to really have a relative min on this problem. I'll go ahead and get started on this problem, and I'll have to finish it in the next video because it is a little bit longer. The first thing I want to notice is I want to take the derivative of this, and I need to rewrite this in order to take the derivative. So I've got sine x quantity squared, that's what that squared part means, plus sine x. When I take the derivative of this, I end up getting 2 sine x cosine x plus the derivative of sine x is cosine x. I can set this equal to 0, which will allow me to find my critical numbers. I can factor out a cosine x, and I'm left with 2 sine x plus 1. So when I solve for cosine of x, I want to know where the cosine of x equals 0, and where 2 sine x plus 1 equals 0, or truly, where the sine of x is equal to 1/2, or negative 1/2.